Welcome, everybody. We are here in our fifth session on digital sustainability, and we are going to be joined by Dan and Danielle from ThoughtWorks. They're going to be talking about Green Cloud. So everybody knows we are ClimateAction.tech. If you're not part of the community yet, join us at ClimateAction.tech. We are a group of climate action professionals in the tech sector, and there's about 4,000 of us. So if you're not part of us, you need to join soon. And no further ado, I want to introduce you to Dan and Danielle and pass it over to you.
Great. Hi. We're really happy to be here. So thanks for inviting us. I'll start with myself. I'm Danielle, based out of New York. I have been doing the role of a product manager on the team with Dan. We're calling it the Green Cloud team at ThoughtWorks in North America. And we'll get into a little bit of what our team has been doing, but we've been building a tool that's going to be open sourced very soon, next week or so, trying to help solve this problem of carbon emissions in the cloud and trying to reduce them. So I've been the product manager and I've been at ThoughtWorks for about 6 years. So that's a little about me. Dan, would you like to pop in?
Hey folks, I'm excited to be here. Dan from New York, based in New York. I'm the Green Cloud tech lead for ThoughtWorks North America. I've spent most of my career building software solutions for nonprofits and climate activist organizations. And at ThoughtWorks, I'm focusing on bringing this Green Cloud solution to our clients, but also to the open source community, which we're really excited to talk more about in the session. I'll throw back to Danielle.
Great. So a little bit of an agenda. We are going to do a quick quiz to start off, get the juices flowing and hopefully hear a little bit from you. And then after that, I'll give a bit of an overview into this idea of Green Cloud, what that means to us and how we can approach it. Then I'll throw it to Dan and he's going to speak to some of the tools that already exist in the space. And also touch on the tool that we've been building and hope to share with you soon. He'll also do a demo next, so get to see a little bit of it. And then we'll finish up with some further ways that you can get involved, some resources and ways to stay up to date with the things happening in this space. And then any Q&A that we don't cover during the presentation. So if that sounds good to everyone, we'll kick it off with the quiz. All right. So the first question is, what industry is the IT sector on par with in terms of carbon emissions? Is it aviation, financial services, tourism, or retail? And just put a letter in the chat if you feel like it. Getting some A's there. CB. All right, so the correct answer is A. You want to switch, Dan? There you go. Officially, A is the correct answer. So seems like a lot of people already knew that one. Great job. All right, next question. So if the internet was a country, it would be the blank largest carbon emitter. So the 12th, the 7th, the 2nd, or it actually reduces carbon emissions. All right, got some B's coming in. All right, so got a pretty smart crowd. The answer is B, the 7th. Cool, on to the next one. So true or false? AWS, GCP, and Azure provide information about their carbon emissions. True, false, kinda, or not really sure what's going on here. Got some C's, B. Cool. So the answer is C. It is kinda. So they don't generally provide a lot of very explicit information about emissions that you as a user are producing. But there is the Azure Sustainability Calculator that is free for enterprise users that is a start to that kind of information. And then not quite exactly this, but worth mentioning is that Google did recently publish their emissions factors and the carbon-free energy percentage. So it is it's not where we would like it to be, but it has been trending upward to be a little bit more open. So, all right, that ends our quiz. So before we get more into the specifics about the different tools that are trying to start to solve this problem of carbon emissions in the cloud, we wanted to take a little bit of a step back and look at the space as a whole. And it is something that, as I said, is kind of trending upward. It is becoming a little bit more public and more talked about. And 2020 was a good year for green tech and for green cloud in particular. So there were a few articles that came out. Two of them that we liked were Accenture's article, The Green Behind the Cloud, and Harvard Business Review's article entitled How Green is Your Software? So these two talked about how, and I think a bunch of us may know this, but moving from on-prem to the cloud it can result in large reductions in energy and emissions. So the numbers they gave for that were 65% reduction in usage and 84% reduction in carbon, which is really good. It's a great start. But then the articles do go on to say that if we design applications to be cloud native, we can actually increase that amount of reductions up to even 98% of emissions reductions. So it really does touch on this importance of building our cloud or our software to be cloud native and the impact that software can have on emissions reductions. So with all of that in mind, they also go on to say that tech should always be designed with sustainability at top of mind. And it should be built in kind of as a cross-functional requirement for development teams. So really from the ground up, we should be thinking about sustainability. And overall, as a part of a company's sustainability strategy, sustainable software and greening your cloud should be a key part of that. So just wanted to highlight that this is being publicized and it is trending, that these things can really make a difference, viewing your cloud as part of your sustainability strategy. So next, we wanted to then think about, okay, if we're going to solve this problem, what's a way that we can break it down a little bit? So it's helpful to think of it in two parts. So the first part of this problem is what the cloud providers have control over. So the first piece of that is the energy source. So what's powering the servers that make up the cloud? Are these renewable energy sources, or are they powered by fossil fuels? And in many cases, the data centers are actually being powered by fossil fuels. However, some of these cloud providers do purchase what we call renewable energy credits. These renewable energy credits, or RECs, essentially pay for the generation of certain amount of renewable energy that accounts for what the cloud provider used, but that doesn't really change that the emissions were generated in the first place. So that's the first piece. And then the other thing that they have control over is the actual infrastructure, the physical infrastructure of the data centers. So that's the building itself and how effective it is. So this metric is called the power usage effectiveness, PUE. And that describes the energy that's needed for things like cooling the data centers because they get really hot, versus the energy that is directly powering the servers. So that bit of maintenance piece to keep it going. So this is what you hear about when cloud providers are doing things like moving data centers underwater, or redirecting the heat that comes out of the data centers. So those are the things that are in the hands of the cloud providers. Then the other piece is what the consumers have control over. So that's considering the services that are being used and the software that's being run. So in that, there's opportunities to look at, for example, how much compute is being used versus storage, memory, and networking. And then thinking about things like how many servers we actually need and when are they running, When do we need them? Is there a way that we can optimize our workloads and move things from move things from servers that are being underutilized, or even turn them off, get rid of them? And thinking about the number and size of the requests and optimizing those, for instance, catering to specific devices or caching. So there are a lot of opportunities that we have as consumers of the cloud. So that's kind of a bigger picture before we dive in. And
Danielle, if I
Dan's
could
gonna,
just
Yep.
raise your attention to or bring your attention to a question in the chat. The question in the chat is, do you tend to factor specialized hardware manufacturing into the total emissions? For example, TPUs for Google Cloud?
I might jump in here real quick. So I'm actually unaware of what TPUs are, Paul. So I need to look into that. But
it's special chips for doing ML stuff, basically.
Very interesting. So I can touch on this in more detail in a little bit when we talk about how our application works in terms of estimating emissions. It currently does factor in Amazon's Graviton processor and a Graviton 2 processor in the way that it works. So we are factoring in that particular specialized hardware for Amazon Web Services, but we haven't quite looked into the TPUs for Google Cloud yet. So that's a really good flag, Paul. Does that answer your question?
Yeah, more or less.
Cool.
I guess it was more like, do you just factor in the energy usage of the data center itself, or the actual manufacturing cost for the hardware as well?
Yeah, that's a great question. We don't currently look at the emissions created in the manufacturing of the hardware, just the usage of the data center itself for now. But we have discussed that with a number of people about how we might take that into account in the future.
Cool, thanks.
Great question.
yeah, I think that's all I had for this. So Dan, if you want to jump in, we'll start getting into that more specific about the tools, how they work, and the one that we've been building.
Awesome, thanks, Danielle. So I'm going to dive straight in and share some existing tools in the space, which folks may or may not be aware of, and I believe at least some of them have, members of this community have been involved in creating. So these are some of the existing tools. So just starting in the top left, in April last year, Etsy published their Cloud Joules methodology that uses publicly available information to determine conservative coefficients to estimate their energy use for compute and storage of Google Cloud. Honestly, it's a really great place to start for Google Cloud customers, and they open source the SQL query that they use. And we also leverage this methodology in the tool that we're building, which we'll talk a bit more very soon. Next up, the Green Web Foundation have published 2 open source tools, and they may have more that we haven't looked into yet. But the CO2JS provides a quick way to estimate emissions from the amount of data your application processes over the network. And Green Cost Explorer allows you to know which AWS regions you were using that are more sustainable, because Amazon purchases and retires environmental attributes for them, like renewable energy credits that Danielle mentioned earlier. There's 5 regions that AWS purchase and retire those attributes for, and it's unclear to me whether it's 100% of the energy in the regions or less, but there are 5 regions that are more renewable because of that. The team at Hubbo built an open source tool called Scafon, I believe is how it's pronounced, that allows you to measure the energy consumption of bare metal hosts and virtual machines. We mentioned it earlier, but Microsoft also provide their sustainability calculator for enterprise customers, which is a dashboard to visualize the carbon emissions from your Azure usage. And lastly, the team at Teads have an open source tool that allows you to measure the consumption of bare metal Linux hosts called TurboStress. That is, yeah, it's also open source. So yeah, these are some of the existing tools in the space that we thought we'd share. And you'll have links in the slide deck to all of these to check them out. So at ThoughtWorks, we've been working on a 2B open source tool called Cloud Carbon Footprint. It pulls usage data from multiple cloud providers and estimates the energy and carbon emissions associated with compute, storage, and networking. It currently supports AWS, Google Cloud, and Microsoft Azure. But we are looking to adding other potential cloud providers or other potential data sources like on-prem or co-located data centers in the future as well. We're working with a small number of innovation partners to prove out the value proposition, and where our goal is to open source the software next week under the Apache 2.0 license. We're thinking this could be a great tool for devs and infrastructure leads who want a more hands-on ability for cloud configuration and usage. And a tool like this, we're hoping will help not only make day-to-day decisions, but large architectural decisions, as well as identifying opportunities for optimizations, reductions. We're also hoping this tool is useful for other stakeholders like sustainability leads and finance leads who are looking to track cost and emissions over time. And here's like a double click on some of those use cases. Often we've found that existing carbon accounting software often targets maybe the sustainability teams or the finance or operations teams. And with Cloud Carbon Footprint, we're hoping to provide value to these users, additional value to these user personas, but also with members of the IT organizations and software development teams. For software developers, we want them to be able to see the environmental impact of the code they deploy, and infrastructure leads to be able to help them prioritize work that not only reduces cost and improve performance, but reduces carbon emissions as well. As Danielle said earlier, we want to push the tech and IT industry to factoring in sustainability as a cross-functional requirement, like security, performance, cost with your usage in the cloud. And often sustainability leaders are needing to report on some of these metrics, and operations teams want to ensure their organizations meets budgets and regulations that we're hoping it helps with as well. So at a high level, how it works is that we query AWS, Google Cloud, and Microsoft Azure APIs to get the usage data. And the application then converts that into estimated energy in kilowatt hours and carbon emissions in CO2 equivalent. Then there are a number of options for how you can view or use the data. Out of the box, there is a dashboard that we provide for you to view the metrics in various charts with a variety of filters to hone in on maybe some of the data points. Or maybe you just want to configure and deploy the API that we've built for other services to make requests and consume the data, which you can also do. We also provide a CLI, a command line interface, to view the data in a number of formats, like a table, like tables, or save the data to the CSV file for your own analysis. Basically, we're really hoping that it can be a plug and play approach where you can consume your cloud carbon metrics in a way that is valuable to your organization. We've heard from a number of innovation partners that they already have their own, data viz front-end dashboarding solution. They just care about the underlying data as a source to plug into some of those data viz tools, as one example. So just to do a little double click on how the tool works, this is how we think of basically estimating carbon emissions from cloud usage. So we first take usage data, and you can see the sort of metrics that we're consuming, the virtual CPU hours, terabytes of data stored, and convert that into energy estimation using best practice methods and the latest research in the space. For compute and storage, we leverage an updated version of Etsy's Cloud Joules that we've, updated some of the coefficients and improved on the methodology that they published by factoring in the underlying processes that we know cloud providers use. I can speak to more detail if folks have questions, but improved in a number of ways that we think. And then for networking, we base this on the latest research in the space, latest research reports. Next, we multiply that by the power usage effectiveness of the cloud providers based on publicly available information. And then finally, we convert the energy use into estimated carbon dioxide equivalent. And we do this by looking at publicly available data sets for grid emissions factors in the locations cloud providers have their data centers. So I'm not sure if folks saw, but Danielle just mentioned actually Google published the emissions factors for their regions. So when they did that the other day, we updated the the coefficients for Google Cloud to use those as they were published. For the other cloud providers, we still just use other publicly available data sets because we'd want some level of confirmation from Google that those could be applied to other data centers in the same region from a different cloud provider. And it hasn't been without a lot of help and support. We basically just want to say a huge thanks to the innovation partners, but also just supporters of the software that we've been working on for all the feedback and, you know, both in terms of running the application and seeing how it works and how we can improve it, but also in terms of the methodology and the approach to estimating energy and carbon emissions. So just a shout out and a big thanks. Okay, now it's time to do a demo, but I want to stop to see if there's any questions about what I went over before we do a demo. So Drew asks, how does the final CO2e tally account for renewable energy credits that a cloud provider purchases? It's a really great question, and it's one that comes up nearly every single time we talk about. So when it comes to reporting on scope 3 emissions, which is what your usage as a cloud provider customer would fall under, we hope, and what our application hopes to help organizations do, we would hope that you would report on them scope 3 emissions like you would report on scope 2, but there's currently no guidelines or regulation around doing that. The way that you report on scope 2 is you report two figures, the location-based emissions, which are the emissions created in the first place that don't factor into account energy attributes by that provider, like renewable energy credits, and then the market-based number, which does factor in account those renewable energy credits. Our application just deals with the location-based emissions for now, because that's a number that we're hoping to help organizations understand and report on. We would definitely welcome contributions to factor in the renewable energy credits and purchasing power agreements from cloud providers. We haven't added it yet, just because it's quite complex. I know Microsoft Azure and Google Cloud every year purchase enough renewable energy credits to match 100% of the energy for their data centers. So theoretically, the market-based number would be 0 or close to 0, but there's a lot of complexity with the level of quality and around renewable energy credits and the PPAs. And so getting more transparency around how to factor that in is, I don't think it is as simple as just saying it's 100% like they have on their website. So we haven't added it yet, but would love contributions. Hope that answers your question, Drew. Cool. I'll jump in with Ali's. Were you able to source information from cloud providers about the energy required for networking between data center locations? Short answer is no. We haven't got information from the cloud providers themselves. The way that we decided to look at networking is we looked at all of the published research papers on networking over the last 2 decades, I suppose. And what we discovered a few things. One is there's a very high variance in the research papers and the coefficients they land on for the number of watts produced for a number of bytes or gigabytes. Very high variance, but there was a trend downwards, like quite a steep trend downwards. And so more recent papers are reporting much lower coefficients for watts per gigabyte transferred. And we also make the assumption that hyperscale data centers, like the 3 major cloud providers we look at, have the most efficient networking with subterranean cables and very efficient, very high bit rate of data transfer. And so we decided for now, at least, to settle on the lowest available coefficient that we found based on research papers and most recent talks. So we feel fairly confident about that for now, because that's where the research trend is going. And I think that the assumptions about cloud providers and the efficiency about data are quite very likely. But again, we would love contributions or additional research in the space for networking. Hope that starts to answer your question, Aled. Cool. Another question from Wilhelm. we'll get to the demo, but I like these questions as they come up. So do you have any plans / ambitions to take a larger part of the life cycle into account, e.g. production or waste management of hardware, or at least a rough estimate of how large parts of total emissions the other aspects of the life cycle may contribute? We don't have specific plans in place yet, but I will say it's definitely an area of interest. One of the hopeful goals of open sourcing the software is that more individuals, rather than our small team of 3 or 4 people at ThoughtWorks, can help suggest or contribute those potential additions to the software. So I would say it's definitely an area of interest. It's not on the short-term immediate roadmap, but again, we want our roadmap to be influenced by the community around the software, and so that could totally change. Sorry, Danielle, I'm making roadmap comments here, and you should be the one answering those sort of questions. Cool. Any others at all? Okay. Let me do a demo. Can folks see you can see my screen demo? Okay. So this is the front-end dashboard application, the project called Cloud Carbon Footprint. And what you're looking at in this first chart at the top is the energy and the metric tons of CO2e equivalent for ThoughtWorks, our internal use of AWS, Google Cloud, and Azure. We have quite a lot of usage internally of AWS and GCP, very little Microsoft Azure, but not a trivial, negligible amount. And it's just showing the metric tons of CO2e over the last 12 months, roughly. I've just grouped the data by month here, just to make it a little bit easier to view. You can also look at, we can also add in here the kilowatt hours, which maps really closely to that, and then cost as well here. Interesting, recently we had a drop in cost, but a slight increase in emissions. We've actually seen that with some of the people using the software, and something that could contribute to that could be purchasing a large number of spot instances with AWS. So that would increase your emissions, but if you'd move from reserved other instance types to spot instance, they're heavily reduced. So that could be something we need to check with our tech ops team, what happened there. But as you can see, there's fairly close mapping between them. We have a bunch of filters we have 330 accounts across the cloud providers. You can also filter by service. So we're using roughly 40 AWS services, Azure 11, GCP 17. So you can select and filter the data based on that. And you can also select and view from different timelines. So if you just want to look maybe at the last 3 months, it's been fairly flat, 12 months and all as well, which is the same. I'm just looking at the data for the last 12 months. So this first view is kind of for maybe for the sustainability team leads, or maybe finance or operations team who kind of want to look at a trend over time, looking backwards over a given time period, where thinking it could provide some value for sustainability focused team members. And then down here on the left, we have what we're calling a carbon equivalency component, basically showing the total metric tons of CO2 over a given time period, but then trying to make that a little bit human, real world understandable. So miles driven, driven in a car, gasoline, gallons of gasoline consumed, and carbon sequestered from tree seedlings. We pulled these just from the EPA's, the EPA Environmental Protection Agency in the US. They have an equivalency calculator. You will note that they are very US specific, which we fully acknowledge, and definitely want to update these to have some more globally relevant examples. For example, the number of round trips flying from London to New York or something. So definitely something we want to try and not just make US specific. And then over on the right here, we have the emissions breakdown by a number of different, by a few different options, by region, by count, and by service. So for ThoughtWorks, the overwhelming majority of our carbon emissions come from Amazon EC2 and Compute Engine, it looks like. We're actually working right now. I was hoping we might have it ready for this demo, but we're working on adding color coding to this region breakdown to show whether, because each region has a different grid energy mix. And so we're hoping to show which, maybe your top 3 regions are maybe slightly browner with that color, and then, or maybe yellow for the middles, or green if it's a more renewable region. So we're going to try and factor that in to give some starting points for like recommendations or low-hanging fruit for what you could do to improve. Longer term roadmap, we want to bake in actual specific recommendations for maybe changing these instance sizes to be smaller ones, but have a higher CPU utilization rate. So you can improve the energy profile of your cloud usage, and other sort of recommendations, because we've spoken with a lot of people and everyone's really keen to do better with cloud carbon emissions. And the first thing a lot of folks have asked is, where do I start? And so we want to try and find a way to recommend where people could start to reduce emissions. And lastly, we have this little component over here that basically just summarizes the formula in a short way and links off to a long detailed write-up that we have in our code base that talks about the methodology. Danielle, anything I missed there I want to add?
No, I think you covered it all.
Cool. Yeah, as I said earlier, we're pulling this data from an API, but you could, you could independently deploy that API somewhere for other services to consume, or if you just want to run the CLI to pull the data, you can as well. We've broken down the app into a number of packages that are like independently published and independently deployable and usable. So you're not constrained to using something that might not be as valuable for your organization. Okay. I might pass back to you, Danielle.
Yeah, so we're kind of wrapping up here, but don't want to leave you with nothing. So we thought we'd put together a few things that you can do going forward if this sparks some interest and you want to do some more exploring. So the first thing is there's actually a good bit out there to start learning and reading up on to get some more information. There's 2 resources that we've put out there that we'd love to share with you. First is our Green Cloud checklist. So that is kind of some of the things we'd hope to start helping you do with the tool. Some of these recommendations, like a starter kit, is kind of how we've been talking about this checklist. So ways that teams can start reducing their emissions. Then the next thing is the Green Cloud article that we've written last year. That is a bit more of an overview of the space, but then starts to go into some of the benefits of greening your cloud and the ways that you can do it. And then lastly is the Etsy Cloud Joules methodology that Dan touched on before and that our tool is based on. So that's a good entry point into how these calculations work. So that's a good read. Then the next thing is, if you're not already part of the CAT community, to join the CAT community. It's clearly a great space. I think many of us have learned that it's a good intersection of climate and tech, and a lot of great, passionate people doing a lot of interesting things, and ways that you can get involved. And then specifically the Greener Infra Slack channel is a good place to go for this green cloud and infrastructure type conversation. And then next, we haven't open sourced yet, but hopefully next week or so. We'd love to let you know when it happens. So we do have a discussion Google group that you can join, and we'll send out a message when we're open sourcing, give you the link to the GitHub and the resources that we've been building to support the tool. So hopefully you'll join us with that. And we do hope that you try out the tool for your organization or for any personal use you may have. And we really would love to hear your story in the early days of this tool. We do want to make this a community-driven effort, and have the product follow the needs of what people are seeing in their real life cases. So we'd love to hear how it's going for you if you do get a chance to try it out. Yeah, I think that's about it. So if we have any other questions, we can open it up now, if there's anything else.
Hi guys. I'm excited to see this get open sourced. As you know, I've been working on a similar kind of tool internally, and I'd much rather use a community-supported effort than just a small group where I work. But I'm curious to know if you've got existing clients that are actually potentially starting to use this, and how you've gone about educating them on the importance of greening up their cloud.
I can jump in. So it really varies. So we've had a number of conversations with some existing clients where there's been a fair bit of interest. The challenge with having an engagement with an existing client is there's already like roadmaps and priorities, and it's hard for this this work not to be seen as another thing. Like we work with a lot of clients to do cloud migrations or cloud optimizations, and they're already very complex, difficult projects to manage. And if you don't bake in green cloud and sustainability kind of from the start, it's more difficult to try and tack it on later. So there's definitely been interest. It's just finding the right way that makes sense for the business. We found that digital scale-ups that maybe already have a track record around sustainability are more likely for this to be up in their priorities, because when you look at the sustainability priorities for like physical manufacturing organizations that also use the cloud, it's often the warehouses and the office, the retail stores that are first to be looked at in terms of carbon emissions. So that's where we've seen more interest. Now, where we have been having pseudo-like client work is with the innovation partners. So we've been working with some fairly large users of cloud software to work with them to use the software to estimate energy consumptions, and work with them to see if we can find some ways to optimize or recommendations for them. Now, I wouldn't call them clients per se, but it's a very much so like a client-like relationship. And so that we've seen some traction there. What we're hoping is that by working with innovation partners, we can provide some value to those organizations, and then have a story to tell, maybe as we open source or further down the road, in a couple of months, once we have some solid stories that we can tell from the software, and then bring those to other clients. So, so it's kind of somewhat of an answer, Drew.
Thank you.
Does anyone have any other questions? Oh, we got one in the chat. Dan, do you want to read it out?
Sure. So a prime motivation is to provide a tool to enable users of cloud services to have a quantifiable comparison of the CO2e impact of their choice supplier. Would one useful addition be to estimate the additional price for carbon abatement from the user company? I'll start to answer it. One thing our tool, when it comes to a choice of cloud suppliers from cloud services, our tool is very cloud agnostic. We don't see much value in saying, recommend move from one cloud provider to another, because what we found through using the tool and with the methodology is that it's highly dependent on your configuration and the way that you're using a cloud provider. And it's not always true that one cloud provider might, reduce emissions or reduce cost by sort of switching. To encourage service provider. So then the second part of the question is, would one useful addition be to estimate the additional price for carbon abatement from the user company? Are you, Nick, and feel free to add in the chat or jump in the call if you want. When you say carbon abatement, is that enabling companies to purchase like energy attributes that match their usage of the cloud provider, or actual offsets to remove carbon from the atmosphere? Just understand what you mean by carbon abatement. Might be typing, Nick. Right. So with scope 3, we would hope that the tooling, it would not only encourage you to understand and bring visibility into your carbon emissions, but also purchase renewable energy credits to match that amount. Renewable energy credits or other energy attributes like that are not what we would call a carbon offset. And a carbon offset is something that to varying degrees guarantees that carbon is removed from the atmosphere to offset the carbon that you produced as part of your supply chain. You purchase offsets for scope 3 emissions. So we would hope that you could then purchase renewable energy credits or another energy attribute to match the energy from scope 3, particularly if you're with AWS and you're using a region that's not one of their more renewable regions, because they're not purchasing those renewable energy credits. We would love it for the tool to be able to have an easy path to do that. We're not there yet, but we would love if we could integrate like APIs for you to like one-click purchase those renewable energy credits as part of maybe the dashboard or something. That would be really awesome to have in the future. Another one from Brian, curious how difficult it is, or if there are any plans to add other smaller providers, DigitalOcean, Rackspace. Sorry if this is already answered. I had to step away briefly. Danielle, do you want to answer this one? Or do you want me to?
Sure, yeah. Just to start, we started off with AWS and then added GCP and Azure. We wanted to initially serve the majority of cloud users. But in the future, yeah, we really do want this to be a cloud agnostic tool for companies using not the major providers, but also companies that are multi-cloud. So yeah, absolutely something that we'd like to do in the future at some point. Not necessarily on the immediate roadmap, but something we hope the tool could grow to be. Yeah.
And I'd also add that we've structured the packages using domain-driven design. So the place in the code base that makes requests to get data from cloud providers is quite separate from the core logic that does the estimation, and then the API and the client, they're all sort of quite separated. So, and we did that deliberately. So if someone wants to come along and as an open source contributor wants to maybe add DigitalOcean or Rackspace, we're hoping that it's fairly clear where that would, where those additions might exist and how to configure the app to support them, and then how to, based on the data structure that comes back from those providers' APIs, assuming they have some APIs, how that might need to be transformed or manipulated to be fed into the estimation algorithm. So it's done completely. Paul, will recording slides be available after this? Yes.
They will.
Right? Is
yes,
that right?
They will. Yeah. The recording will be on YouTube, and we'll share the slides and some notes in Slack.
I've got another question. You touched on it briefly earlier about spot instances, and how it showed by using more of them, it actually maybe showed an increase in carbon but a decrease in cost. And if we're trying to have a tool that's intended to incent people to make decisions that are going to be the greenest, and I feel that using spot instances are a really smart choice in that particular sense, in the sense that we're using capacity that's already running and burning, burning fossil fuels. We might as well make it utilized. But how do you envision creating the right kind of incentive to visualize that and allow customers or users of these tools to understand that it's actually a good decision?
Yeah, don't have a clear-cut solution, but I might jump in with a few thoughts. So one thing we have thought about is like a green cloud score, where it could be based on certain decisions you make. So using a spot instance might positively contribute to that some sort of score. Migrating a workload to serverless might from an EC2 instance might also contribute to that score positively. Reducing the number of instances you have, but increasing the utilization rate, moving data from, readily available Amazon S3 bucket to Glacier, which we're very confident is much lower, energy requirements. All these things could contribute to some sort of scoring system. And the longer term vision that we would love to work on, with the CAT community and users of the software is if we could have an option for users of the software to select to send some of the computed estimation values and maybe their score or some of those attributes that went to the score, along with the size of the company, the type of industry, number of employees, to some sort of central data store where we could actually analyze and work out what does good look like, what does not good look like. And so imagine some company, sign in, I not only see my metrics over the last 12 months, but I see how I compare with similar size and type of organizations in the future. And so that's the sort of thing where I see some of these spot instance choices could be factored in as well. Another thing this is not very scientific and it's kind of hand wavy, but we could have this would be a simple implementation. We could try and work out because if you move to a lot of spot instances or deploy a lot, you will see the amount of energy increase, which is not a great incentive, right? But we could somehow factor that in somehow and either, come up with some sort of coefficient that visually shows that in the bar chart or something that, despite that decision in the short term looking like an increase, there are positive implications for all if we all decide to use spot instances. So somehow visually showing that. So not a great answer, Drew, I'm sorry, but just some thoughts because it's a tough problem.
I've got one for you. So I'm curious about prioritization essentially and making this a dashboard that helps us to make prioritization decisions. So you've already got breakdowns based on region and based on service types. Are there any other breakdowns that you think would be useful for teams or that teams have talked to you about that would help them to make easier prioritization decisions in dealing with these emissions?
Danielle, do you have any thoughts on this one?
Yeah, I can start off. One thing that has come up is that the way that companies are using accounts or services aren't necessarily tied to their business unit. So there's been a hope from some of them that through the dashboard, they could somehow identify where in their organization the most emissions are coming from, if there's specific projects or teams or arms of the organization. So that's something that in the future, it would be really great if we could show somehow. And one way to do that is if a company is using tags really well, we could build that in possibly. However, not all organizations always use tags great. So there's definitely some thinking that we'd have to do to start making progress toward that. But that's something that's kind of in the back of our minds of that would be really cool if we could do that.
Amazing. Does anybody have any other questions? I'm conscious we're a couple of minutes out and we weren't able to get to breakout rooms, but this has been a really good session and some really good questions. So, oh, we've got one just coming, popped in.
Alid is talking about another integration that we might have, we may have already considered, InfraCost CI tool, which estimates the financial cost of each change to Terraform code. Super interesting. I haven't heard of InfraCost. I haven't seen InfraCost. I've looked at a number of other similar, like not similar necessarily, but some tools around looking at cloud spend and performance and things. But this is interesting. We should look into that. Another actually.
I was going to add that, you know, Terraform Enterprise actually has this cost built into it, and I've been asking HashiCorp to see if they can add some kind of emissions-related data as well before you apply those changes.
That would be awesome. Yeah, being able to preempt. We've thought about notifications when there are spikes, but that's post-fact. Being able to preempt and model into the future, for sure, would be amazing. We've also looked at a hot trend is, not a hot trend, but a lot of organizations are starting to adopt developer portals. Spotify built one for them internally, and then they've open sourced it called Backstage, and it does a lot of cost. One of the plugins is around cost optimization and recommendations. And so integrating some of this into developer portals is another potential use case. What's the best way for people to get involved with the open source project? I think signing up for our discussion, we've got just Google group, discussion group for now, because then you'll be notified as soon as it gets open source and you can get all the links and stuff. That'll be in the deck. The link to that will be in the deck. And the tech stack is a TypeScript React front end for the client, and then all the backend packages are a TypeScript Node. Thanks, Melissa. Just put the link to the discussion group.
Amazing. Teamwork makes the dream work, right? Awesome. We can continue the conversation in Slack. I think we're using Green Infra, and obviously in CAT/Salon if you can't find that. Thank you, everybody. Thank you, Dan. Thank you, Danielle.
Thanks, folks.
Enjoy your rest of your day.
Thanks,
Thank
everyone.
you.
Yeah.